All right, cool. Welcome everyone to joining this month Hudi Community Developer Sync Call. Uh, my name is Xu. I'm a PMC member of a Hudi project. Um, Today I'm happy to have Ethan, who is also a PMC member of Hudi, to join and talk about the upcoming releases, Hudi 1.1 and 1.2, to share some highlights. All right, Ethan, feel free to start with some, yeah, with your content.
Yeah, thanks, Shian. So hi everyone, as you all know, we have put up the Hudi 1.0.2 release in early May. So our next two release will come in the next few months. So for the 1.1 release, we plan to release it sometime in June this year, and then after like 1 or 2 months, we plan to release 1.2. So as you can see on this roadmap page on our website, we have already laid out what's planned for 1.1 and 1.2 releases. So for today, I'll mainly talk about one main area that we spend a lot of effort to improve, and which is also the differentiator of Hudi 1.0, which is the indexing subsystem. So we want to, as you all know, like Hudi 1.0 has this vision of bringing database functionalities on Lake and or like the database experience on Lakehouse. So what we have spent in the last few months is to improve the performance and reliability of indexing subsystems and also making it more flexible to add new indexes. So specifically, I want to first talk about
Ethan,
one.
could you zoom
uh,
in a bit, make the font bigger?
yes, is it better?
Yeah, looks better. Uh,
Okay,
yeah, this is good.
cool.
Cool. You can also use there's a marker on the screen if you're able to maybe draw something. I don't know if you see any button to on the
Let's
like,
see. Okay, I can see it.
yeah,
Does it work?
yeah, it works.
Okay,
Cool.
cool. Okay, so
Is there like a temporary one that can go away after that? Like
yeah, let me try.
pointer, maybe there's a mouse. uh,
Are you able
I
to
don't
see my
know.
mouse? Or
Yeah, I can see. Yeah, I can see your mouse. Maybe, yeah, just your mouse is fine. Yeah, I think that's
okay,
that's how it works.
okay, sounds good. So yeah, so let me first talk about this new feature where we want to improve the reliability of metadata table, especially for record index. So as you know, Spark is a like a distributed like compute engine. So um, in production cases, usually what we do is we dynamically scale up and down executors based on the load. And one issue we see running like metadata table or ingest or creating or updating indexes on Spark is that to get around this Spark dynamic allocation and retries, we need to make sure that any task retries should be reliable without generating inaccurate or incorrect results. So currently what we did is whenever we write data files, we have commit metadata, we collect them into like the driver so that it's deterministic, and then we generate metadata table updates from the commit metadata. However, these can lead to performance bottlenecks and then rereading or rescanning the data again, which can lead to like performance degradation or poor performance for metadata update. So so from the developer side, we kind of have this new design of the new red deck for updating metadata table. What this does is it removes the artificial collect stage for collecting the commit metadata driver so that this metadata data table rights and metadata table rights are unified in the same DAG. So it better leverages the resources in Spark job, and also making it easier to maintain and making it reliable and then robust against Spark retries. So this is like one big improvement, which is under so the design is done, and then the changes for PRs are under review now. So I encourage all the developers to join this discussion, because this will be the de facto right process or right job or right deck on Spark going forward for both data and metadata table.
Oh, just maybe just to confirm, maybe my understanding is like in summary, this is kind of previously we were doing this update metadata after we committed finished writing to the data table, and now it's kind of combined into one DAG in Spark, so that writing to data table and metadata table are kind of part of the same DAG. That's something to
Yeah,
catch the essence of it.
yeah,
Cool.
that's correct. And what's even better is that previously, let's say for record index, we have to collect the commit metadata and then the list of files. Then we have to scan the data files again to get the record keys and the location to generate the updates to the record index in the metadata table. Now we have the opportunity to say, okay, since we can compose the DAG alongside data table, we can actually derive the update record directly from the data records. So this also reduces the I/O to storage. So this will also improve performance.
Okay. Yeah, other than performance, do you see like any other improvement, like aspects for improvement? For example, is it gonna be more reliable?
Yes, so by design, we make sure that all the retries, so this DAG is kind of robust to retries. The reason previously we collect on Java is that so remember in Hudi we have this reconcile stage where, let's say, if there are task retries in the data table right stage, we at the end we reconcile it against the marker so that we remove any dirty files that do not belong to the commit metadata. So
Yeah.
similarly, we don't want the dirty files to appear in any of the metadata we track in all different indexes. So previously, you have to do collect driver. Now we use a different way to guarantee this so that it's both performant and reliable.
Okay. Cool. Cool. I think that's definitely a great direction. But I was thinking is this is only applicable to Spark, right?
Correct.
Um, how about like Flink and any other engine that needs to integrate such process?
That's a good question. So for now, Flink doesn't have such a problem, and even the integration of record index with Flink is still under development. So currently, this stack is for Spark only. But I believe that in the future, let's say if the engine has um, similar characteristics as Spark, then we can potentially expand this framework to support different engines.
Okay. Cool. Yeah, that's all I wanted to ask. Thanks.
Cool. So that's one aspect on the right side for metadata or indexing subsystem improvement. The other aspects is we want to introduce new indexes. I think last time Sean has presented this bitmap index. And during the development, we realized that the current framework of supporting like a new index is not that flexible. The reason is that originally we designed this metadata table for file listing only. And as we add new indexes, it becomes harder to maintain. So in 1.1, we are going to introduce a new index abstraction on both reader and writer side. So what this means is that in the future, whenever a user or developer wants to integrate a new index, let's say bitmap index or the vector search index, which is also listed or on the plan for 1.1 release, they only need to implement this index interface or indexer interface. And all the details of handling transactions in metadata table or how to properly handle clean or different actions, those will be abstracted out. So the user doesn't have to worry about those. They only have to worry about, okay, so for this index, how do I define the index data or metadata to store in the metadata table? How I insert, update, and delete the existing index entries? And is there any additional table property or config or index definition I need to update? So in this way, and then in addition, we also provide, so along with this index abstraction production code, we also provide a kind of base test class or framework so that the developer can easily add new tests on new index type. And then we'll provide all different test suites so that, okay, the developer knows what kind of cases he or she needs to cover to make sure it's production ready, or yeah, it's at least like all the major cases are covered. So this will make adding more indexes much easier. So this is one big thing, another big thing in Hudi 1.1 release, because going forward from release 1.2 and beyond, we want to add more and more indexes because that's one of the differentiator we want to bring to the Lakehouse platform or Lakehouse framework.
Yeah, that's really useful. Actually, this is being I think that the community has been looking for the kind of unification or abstraction for a long time because there has been so many index being added in the past, from
Yeah.
Bloom simple to HBase, and now we have secondary expression index, all these new features.
Mhm.
Um, yeah, it's definitely good to see a unified API. So I also wonder, so would we kind of it's kind of already a repeated pattern we see in all this indexing management that we always do a similar sort of operation like create index, delete index, update index. This is this is more like applicable, I would say, to record level index, those sort of but maybe only those that affects the persistency layer. Um, but for those like Bloom or Simple, these are kind of non-persistent index. So there's kind of some index fall into this category, right? This abstraction.
Right. So yeah, good question. So this abstraction is more for the query engine side, the
Okay,
read side index. I
okay,
think
I see.
let's say the Bloom or simple index, yeah, I assume you're talking about the writer side
Yeah,
index, which we leverage for looking at the records or to identify inserts, updates, and deletes. I think this index abstraction will still be useful because, for example, for record index, it's used on both reader and writer side. Uh, but for maybe for, let's say, bitmap index may be used only for the reader side, like for query engines. So for now, this indexer abstraction is more for like adding new indexes in metadata table.
okay,
And it could be used for writer side as well, but main use case is okay, the query engine should be able to use it to optimize the query performance.
okay. I see. So it's mostly when this index is being added to metadata table, we want to have standardized APIs so query engine can easily integrate with those.
Correct.
And when we update those indexes, it's for the writer to also kind of use the standard API to update, create and update, right? That's the what do you mean by here for writer and reader?
Exactly.
Okay, got it. Cool.
Cool. So let's move on to the third one. So I think you mentioned about HBase index or even like the H file in metadata table. So I think as we know for H file powered S is the kind of the key values or key value store or SS table file format powering the metadata table in Hudi. So in 0.15 release, we have introduced the native H file reader so that engines like Trino, which does not rely on Hadoop file system or dependencies, can leverage the native H file reader to support metadata table read. Now in Hudi 1.1, we are going to introduce native H file writer so that both reader and writer can be independent of H-based dependency, and we plan to remove the H-based dependency going forward. This is good in a sense that we now control like the full read and write on the kind of the I/O side or like the interaction with storage for each file. This opens up more optimization for us. For example, we can add caching, we can add how we read each file in an optimized way for cloud storage. And similarly, as we introduce the Java-based native HFL read and writer implementation, we can also expand this to Rust, even Python or other languages, so that we don't have to say fully rely on H-based Java implementation, which does not have other language reference implementation reference. So these native H file writer along with the reader implementation in Java will be the reference implementation, and it can be replicated by other languages going forward. So this is another big thing because we want the metadata table to be extensible, flexible, and then it can be read not just by Java readers, but also like other languages or other language bindings. So this is another big step we are making in 1.1 release.
Nice. Super exciting.
Cool. I think let's see. Other important improvements in metadata table include non-blocking concurrency control in metadata table. So right now, even if there are concurrent writers, even if for data tables, they can use OCC or optimistic concurrency control.
Right.
Right.
Could you point to which item are you referring to?
Yes,
MBCC
this one.
for MDT. Okay,
Correct.
cool.
This one. Yeah, so I was talking about multiple writers on data table can write data files in like a concurrent way. But whenever they commit to metadata table, it has to be sequential. So it has to be in single writer mode. So that can still affect performance. So in 1.1, we plan to introduce non-blocking concurrency control on metadata table, meaning that even metadata table can have non-blocking concurrency control. So multiple writers can commit to metadata table in concurrent way without affecting correctness. So this non-blocking concurrency control we already introduced in 1.0 on the Flink writers. Now we make it available to MDT so that it further improves the performance for concurrent writes.
Cool. Yeah, that's actually yeah, kind of bottleneck for like high concurrency writes. If they're like and metadata, if they enable metadata, it will be a problem before with
Uh,
MVCC. Yeah, that's really comes in nicely with this setup. Yeah,
Right.
and MBCC is actually meant for MOR table
Correct.
only, and then metadata table happen to be MOR. I mean,
Yeah.
by design it's MOR, so that's a good like choice there.
Yeah, exactly. So let's see, beside that, uh,
Ethan, one question I had is is the is there like a specific class of multi-writers that we're going to support in NBCC, or is it um just related to the metadata operations?
oh yeah, so this is more for metadata operations. So even I think okay, I think I kind of get your question. So let's say even if you have async table services on the same table along with the ingestion writer, they both of them can write to metadata table concurrently, and that can be achieved through non-blocking concurrency control as well, if that's your question.
Got it. Got it. Yeah. Yeah.
Okay, sounds good.
Combining this with the earlier item you talked about, the unified stack for Spark Writer, right?
Mm,
So would you say like okay, MVCC will be kind of enabled by default for metadata table? Is that something we want to make for
yes.
this item?
Yes.
Okay.
Right. So with the new DAG, we have to enable MBCC because in the new implementation, we start the metadata table transaction. So we first start the data table transaction, then immediately after that, we start metadata table transaction.
Yeah.
So metadata table transaction is longer. That's why we want to enable MBCC. That's one reason.
Okay.
Previously, we only start metadata table transaction when after we finish writing the data table files. But now we think that that's more like a constraint we had previously because we cannot achieve non-blocking concurrency control on MDT. We have to use single
Hmm.
writer. Now we can relax that constraint and make it more streamlined.
Okay. Yeah. Nice.
Yeah, I Yeah, so that's okay. One more thing I can touch briefly is in the metadata table reader path, we have a custom code on merging MDT file groups and other places where we directly leverage the log scanner in MDT for building metadata inserts and updates. So we are also unifying those by removing such custom code by directly using the file group reader within MDT so that we remove all such complexities. So it's much easier to maintain. This means that we are also going to have like a new merger for MDT payload, and making it much more efficient and easier to maintain.
Okay. The reason why we need a specific merger for MDT payload is there something special about the MDT record ordering sort of logic there?
So So currently we have the metadata payload implementation. So for different index types, we have different merging logic. That's why we have the payload.
Yeah.
And the reason we want to replace it with merger is that we also have another story to deprecate the payload. So we are going to use merger classes by default.
Yeah.
So yeah, so implementing a new merger on metadata payload or metadata uh, kind of information is kind of the dependency or like a blocker for that story.
I see. Yeah, I kind of I can see because each partition has different kind of record for different indexes. So the merging logic would kind of need to handle, for example, what partitions have you enabled for this table, and then you will kind of perform different things. Is that something we need to consider for this merger class?
Correct. So how it's designed now is that we have this metadata payload class, and each index is kind of one field in this like a one
Okay,
like a record field within this arrow schema. So whenever we add a new index, yeah, we add a new field, and then we need to take care of the different like merging logic for this particular index type.
I see. Cool. I also have a related question to the indexing. So we have the like unified indexing abstraction for query side and updating the indexes. So that's also gonna kind of make the indexer indexing table services also unified by that. Is that something we also updating and improving?
Uh, so you're talking about async indexer.
Yeah,
So yeah, so async indexer currently we plan to maintain as like a separate, still maintain as a separate table service so that
yeah,
user can build index like on demand. Right now its design is ready in like a modular way in the sense that okay it calls the metadata table writer to do initialization or updates. So in terms of the abstraction, there's not much we can improve there. So we'll keep that. But definitely in the future, I think we plan to do more testing and then improve reliability of that because right now we support we kind of support, let's say, like async building of indexes, but if index building takes too long and you cannot catch up, there may be issues. We haven't addressed that yet. But usually what user will do is let's say I want to build like a secondary index, they can build the index first while the ingestion is going.
yeah.
So the indexer can automatically catch up after some time. So that's the current model, and it's good enough for now. So we will keep that this way, like in async as a like async table service.
Yeah, exactly. I think just maybe to clarify what I think is because we are giving so more and more index for
Right.
user to add. Like for example, secondary index people can maybe add 10 columns for secondary index,
Uh-huh.
and it will be more important kind of to have indexer, the async indexer to work. Yeah, more. I'm just thinking this will be more of a kind of default choice for
Uh,
people who would like to add so many indexes.
uh,
Then it's kind of it's kind of the obvious choice to make that also unified with the abstraction.
mm,
But I'm just saying, yeah, in a kind of a code level, since you have the abstraction, I was just wondering, i- would that make sense to obviously to apply it to also indexer internally? So obviously
yeah.
user wouldn't care, wouldn't know about what's happening, but at code level, you should also leverage that. But it's not like happening soon, right? It's like for future improvement. That's what
Yeah,
I wonder.
got it. Yeah, actually, so if we look at how the async indexer class is organized, it actually wraps around the metadata writer directly. So uh it
Okay.
doesn't it doesn't directly use different index types there. So so right now the after let's say this indexer or index abstraction is landed, it
Okay.
happens in the metadata table writer. So it's going to be automatically leveraged by the async indexer.
Okay. Okay.
So
That's
that's
cool.
Yeah, as you can see, it's very cool. Like it's kind of laid out in the good way already.
Nice. Awesome. Okay. Yeah, thanks for the clarification. Any question from other audience? All right. So if no more question, we can wrap up this session. Thank you so much, Ethan, for giving us this sharing this useful info. Yeah, see you next month.
Thank you, Shane. Thank you, guys. See you.
Thanks.